Well, hello everyone. Thank you for attending my presentation on the National Spatial Reference System Modernization, and I'll be explaining the new datums. As I said, my name is Dan Determan. I'm the NGS's Northwest Regional Geodetic Advisor. The Northwest region includes Washington, Oregon, and Idaho. And you see some contact information there. At the bottom is my email and phone number, and I'll show that again at the end. So just a little bit about our organizational structure. I know it seems a little odd, but we are a line office within the National Ocean Service. That stems from our legacy agencies such as the U.S. Coast Survey, and you'll see that in my next slide. But like I said, we are a line office within the National Ocean Service. Within NOAA are the National Oceanic and Atmospheric Administration, which is part of the Department of Commerce within the executive branch of the federal government. And National Geodetic Survey has approximately 175 employees. A little history. We are our nation's first civilian science agency. We are more than 200 years old. We were established in 1807, back when Thomas Jefferson was president, as the Survey of the Coast. In 1811, Ferdinand Hassler became our first superintendent, and in 1836, we became the U.S. Coast Survey. During that time, in 1871, Congress tasked us with moving geodetic control inland, and we've basically been doing that ever since. In 1878, we were renamed the U.S. Coast and Geodetic Survey, and in 1970, NOAA was established, and we've been the National Geodetic Survey ever since. So NGS's mission is to define, maintain, and provide access to the National Spatial Reference System, or NSRS, to meet our nation's economic, social, and environmental needs. The NSRS is a consistent coordinate system that defines latitude, longitude, height, scale, gravity, orientation, and shoreline throughout the United States, and the changes that occurs over time to those. So the NSRS provides a consistent coordinate system throughout the nation. We provide the positioning framework, our foundation for all geospatial products. On the right, you'll see all those different layers, and the foundation of all of those is the National Spatial Reference System, or NSRS, which is our main priority, is maintaining, providing, and providing access to that NSRS. So these are all the federal users of the NSRS. Each of these has a member on the Federal Geodetic Control Subcommittee, so that there is interaction between NGS, which is the provider of the geodetic control, and then all of these users of that geodetic control. And then particularly these 5 federal agencies we directly support with the NSRS. NOAA uses our positioning data for referencing NOAA's nautical charts and many other geospatial applications. FEMA uses NSRS elevations to determine flood zones for the National Flood Insurance Program. Army Corps of Engineers uses NSRS elevations to determine levee heights and positions in their levee safety program. The U.S. Geological Survey uses NSRS to geospatially reference their topographic maps and interior water data for the nation. And the National Geospatial Intelligence Agency uses our gravity data to accomplish their geospatial mission. So today's NSRS currently is the North American datum of 1983 or NAD83 and North American vertical datum of 1988 or NAVD88. Today's NSRS consists of those brass and aluminum discs that you see physically installed around the nation, and we call those passive control marks, and that is up until recently was your primary access to the NSRS, but that is changing with the NOAA Cores network and active stations. So NSRS modernization is not just new datums, although we will be replacing NAD83, which is covered in the blueprint for 2022 Part 1. We'll be replacing NAVD88, which is covered in blueprint for 2022 Part 2. And then we'll also be reinventing the blue booking process, improving the Geodetic toolkit, and providing better surveying methods. All of those are covered in blueprint for 2022 Part 3. We have updated all the blueprint documents. Initially, the first two were published in 2017 and the third in 2019. And all three have been updated in 2021. They're all available on our website at geodesy.noaa.gov/library. So modernizing the NSRS includes updating all NSRS coordinates, which means replacing existing datums with the new datums, replacing the existing state plane coordinate system of 1983 with the new state plane coordinate system for 2022, and accounting for coordinates changing with time. We will also be improving NGS products and services, simplifying customer contributions, and basically making the NSRS more accurate, more accessible, and more efficient. The initial rollout is still planned for sometime in 2025. So replacing NAD83 involves these 4 tasks, and I'll cover that at the bottom, the shift and drift. So first, developing the 4 plate fixed reference frames. Replacing the NAD83s. The old NAD83s were NAD83 2011 for both the North American and Caribbean plates. And then we had the PA11 and MA11 for the Pacific and Marianas. So the new 4 plate fixed reference frames will be the North American, the Pacific, the Caribbean, and the Marianas terrestrial reference frames of 2022 are NatRef, PatRef, CatRef, and MatRef. And these are the 4 tectonic plates that are associated with the terrestrial reference frames. You'll notice that the names of the plates are the same as the name of the terrestrial reference frames. So today I'll talk about the North American Terrestrial Reference Frame of 2022 or NatRef 2022. I will use NatRef 22 as my examples, but the same applies for each terrestrial reference frame. I'll now talk about removing the non-geocentricity of NAD83. So you see NAD83 and ITRF 2014 both use the GRS80 ellipsoid. So the size and shape of the ellipsoid is the same. However, the origin is off by 2.2 meters between NAD83 and ITRF 2014. That origin is also what's called the center of the mass of the Earth. So we will be shifting that origin by that 2.2 meters, which will cause a shift in your coordinates. And this is a slide that shows that geometric change due to the ellipsoid non-geocentricity and correcting that origin, making that shift. And you see there on the left is the horizontal shift, and on the right is the ellipsoid shift, or the ellipsoid height, and it looks like those are all downward in the continental US. So this is just more defined estimates of the horizontal change in coordinates from NAD83 2011 to NatRef 22. You'll see for Idaho that is basically approximately 1.4 to 1.5 meter shift, and this slide shows that a little bit better. Again, this is the horizontal change between NAD83 2011 and NatRef 2022. And the direction of shift is to the northwest. So I'll talk now about aligning the ITRF 2020 at epoch 2020.00. So a little bit about the ITRF, or the International Terrestrial Reference Frame, is a stable coordinate system that allows us to measure change over space, time, and evolving technologies. It's an accurate and stable set of station positions and velocities. It's a network. These network measurements are interconnected by co-location of different space geodetic techniques, which there are 4: GNSS, satellite laser ranging, or SLR, VLBI, which is very long baseline interferometry, and then DORIS, which is Doppler orbital radio. I'm not sure. Anyway, it's Doppler. I'm not recalling the acronym right now. So the ITRF approximately represents the motions of the tectonic plates with respect to the Earth's deep interior. And I'll show a little animation of that here. You see the ITRF is a constant frame, and you see the plates rotating underneath of that constant frame, showing the drift of the plates and therefore the drift of the coordinates. So regarding the 4D alignment, or the time alignment, there is one epoch where ITRF 2020 coordinates will be equivalent or equal to NatRef 2022 coordinates, and that is at 0 hours and 0 minutes on January 1st of 2020. That means that ITRF 2020 epoch 2020.0 is equal to NatRef 2022 epoch 2020.0. And from there, they will diverge. And now I'll talk about removing most of the tectonic plate rotation from ITRF 2020 by using Euler pole parameters. So there are 2 types of drift. You have the tectonic plate rotation, which is horizontal, and then you have everything else, residual motions that are left after the rotation is removed, regional linear motions, and then you also have localized subsidence or uplift. The tectonic plate rotation is simple to model. Everything else gets very complex. So I'll talk a little bit about the tectonic plate rotation and removing that. We do that by using Euler pole parameters of 2022, or EPP 2022. In the ITRF, many tectonic plates have a dominant motion or a rotation. The Euler pole is that point about which a plate rotates. In the case of North America, that point is that yellow star off the west coast of South America, and the rotation is counterclockwise. So we use those Euler pole parameters, which are the latitude and longitude of that yellow star off the west coast of South America, and speed of rotation. We apply those parameters to get to NatRef. So with ITRF, you have a frame which is constant, and the North American plate is rotating under that constant frame. With NATREF, you have a rotating frame that rotates with the plate and is therefore constant with the plate. And I'll show a little animation of that. So this is the ITRF. Notice the constant frame and a rotating plate underneath. And this is NATREF, where you have a rotating frame that remains constant with the plate. And we call that plate fixed. So you can get your coordinates in ITRF or NATREF. It's your choice. You just use the Euler pole parameters. However, you do have to know your epoch for the data. So as I said, you can get your coordinates in ITRF or NATREF by using the Euler pole parameters. So this slide shows the core's velocities in ITRF 2014. Notice the rotational motions. You see that arrow in the bottom left of the diagram that represents 20 millimeters of movement per year, which is about what you see across the U.S., continental U.S. Notice the plate boundary there in California where you have all kinds of weird things going on. So if you're working at those plate boundaries, there will be some issues you'll have to deal with. You can use one terrestrial reference frame or the other, and I can talk about that more if you have any of those issues. So this slide shows the chord velocities in NatRef 2022. You can think of this map as ITRF 2014 with Euler pole parameters of 2022 applied. And you'll notice there is still some drift. You see all those little dots out there. That is actually some residual motion after the tectonic rotation is removed. So as I said, initially you'll have your coordinates in ITRF. Actually, that should be 2020 now. The slide's dated. So you'll have your coordinates in ITRF 2020. You'll apply the Euler pole parameters for the plate that you want and get those coordinates in the terrestrial reference frame of 2022 on the plate of your choice. So as I said, there are two types of drift, and I talked about the tectonic rotation, which is the simple part, and then you have everything else, which is the remainder of the drift. And to remove this, or to deal with this, we will use the interframe deformation model of 2022, or the IFDM 2022. So this is the concept of the goal of the interframe deformation model. You see the blue is coordinates of DI4044 in the ITRF, where there is a trend of approximately a negative 14.3 millimeters per year. And then with that plate rotation removed, in that ref, shown in the red, and that trend is still negative 1.7 millimeters per year. So there's still some drift that remains. So again, this is the core's velocities in NatRef 2022, and that's with the Euler pole parameters to remove the plate tectonic motion, and it shows that there's still some drift left over. And again, we will deal with that with the interframe deformation model. So as I said, there's still some drift. Everything in the world moves. The coordinates will be associated with the actual date when the data was collected. The velocities at all marks can be estimated using the interframe deformation model. And the interframe deformation model goal is to move collected data through time to reference epochs for coordinate comparisons and analysis. So a little terminology regarding epoch. It means an instant or a moment in time. In astronomy and geodesy, we use a decimal date. For example, 2021.4762 equals the 23rd of June of 2021 at 1900 hours and 16 minutes, 0 seconds. Using epochs is important, not your format. Please start preparing to assign epochs to your data. It's going to be very important moving forward to the modernized NSRS. So the wrong question to ask after 22 is, what's the position of that point? The right question after 2022 is, what is the position of that point on some specific date and time? So a little more terminology as far as changing coordinates. We will use the word conversion to mean changing the type of coordinate. For example, changing NAD83 2011 latitude and longitude to a NAD83 2011 state plane coordinate system. We will use the word transformation to mean changing the datum of the coordinate. For example, changing NGVD 29 height to a NAVD88 height, or NAD 27 latitude and longitude to a NAD 83 2011 latitude and longitude. And then what I have been speaking about is propagation, and that is to change the epoch of the coordinate. For example, moving a NatRef 2022 epoch 2020.00 coordinate to NatRef 2022 epoch 2023.243 coordinate. So the previous vertical datum was the National Geodetic Vertical Datum of 1929, or NGVD 29. That was replaced by the North American Vertical Datum of 1988, or NAVD 88, which is the current vertical datum. That will be replaced by the North American Pacific Geopotential Datum of 2022, or NAPGD 2022, pronounced NAPGD. So this is a slide that just shows the development of the previous vertical datums for NGVD 29. You see all of those different tide gauges on the coast, and all of those tide gauges were held fixed for NGVD 29. On the right, there's just one, and that's Father's Point in Canada. That is the only tide gauge held fixed for NAVD 88. And this slide shows the amount of leveling that went into each of those. On the left, you see the leveling that went into NGVD 29. And I would say about 1,000 times more leveling went into NAVD 88 on the right. So these are all of the current vertical datums of the NSRS. You see that many islands came up with their own leveling. They basically had a tide gauge that they leveled from and established their own vertical datum on that island or that territory. So replacing NAVD 88, we will be replacing all of these old things. NAVD 88, you've got the Puerto Rican, the Virgin Islands, American Samoa, Northern Marianas, and Guam vertical datums. You have the International Great Lakes datum of 1985. You have your gravity model and your geoid model and your deflection of the vertical model. Those will all be replaced with the new North American Pacific Geopotential Datum of 2022, or NAPGD 2022. This will include Geoid 2022, Deflection of the Vertical 2022, Gravity Model 2022, Digital Elevation Model for 2022, and then a lot of other things, such as the interframe deformation model. So a huge component of this effort is GravD, or Gravity for the Redefinition of the American Vertical Datum. We have recently completed all of GravD is now done. That was a huge part of the delay, so it's a great accomplishment to have that all done. We are currently reflying a few places. I know we're redoing some of the Gulf lines because they were initially flown at 35,000 feet, and we're now reflying those at 20,000 feet. And there were some other smaller anomalous regions that I believe we're reflying, but basically all of the initial data collection has been completed and is in processing. So this is the estimated change in arithmetric heights, changing from NAD83 to NAPGD 2022. You'll see in Idaho, you're looking at approximately 0.8 meters to 1 meter downward or negative. And then regarding NAPGD 2022, it is a geopotential. It is wholly gravity based. There is no leveling used to define it, none. GNSS will be your access. You will collect data and submit it to Opus. There will be no leveling necessary unless you're really looking for the highest accuracies possible, such as for levees and flood zones. And in that case, you will also be collecting GNSS data on some of those marks that you level to as well. Excuse me. And then NAPGD 2022 is based on global mean sea level, and the geoid will change when some sea level threshold has been crossed. And I do have a slide at the end. If there's time, I can show you that. So this is the modernized NSRS. You see that those passive disks on the corners of those layers are now replaced with active NOAA cores network stations. We call those active stations, where they're continuously collecting GNS data 24/7. You'll see that the modernized NSRS will consist of the North American, Caribbean, Pacific, and Marianas terrestrial reference frames are NatRef, CatRef, PatRef, and MatRef for 2022. And then you see on the bottom right is the new all gravity geoid, and that is the North American Pacific Geopotential Datum for 2022, or NAPGD 2022. So why modernized? Well, the current datums, NAD83 and NAD88, were defined before GPS technology and rely on physical survey marks in the ground that continue to deteriorate, be destroyed, and just move over time, and they have not been reobserved. Modernization will improve the accuracy, access, and alignment of our positioning systems, and it will also change coordinates throughout the U.S. by up to 2 meters. So the main benefits of the modernized NSRS is you will get fast, accurate, and consistent elevations everywhere. You will get improved public safety through better floodplain maps and emergency route planning. And you will have more accurate positioning for autonomous vehicles, smart cities, etc. Timeline. Resources are being diverted from tool building to the assurance of quality data first and foremost. As such, based on this new approach, NGS anticipates the release of all data and limited tools by the middle of 2025, and work on additional tools will continue in the out years. And that's my presentation. If anyone has any questions, I'm happy to answer.